So hello viewers, welcome back to my channel, our physics channel. Now last lesson we finished on floating and sinking, and this lesson, our 8th lesson, we want to start on a new topic, and that is thin lenses. So we're going to look at thin lenses. We're going to look at thin lenses, and we need to understand one, what is a lens, okay, and why do we want to go through this topic? Why do we want to learn? What are we going to learn? What is the objective of this topic of thin lenses? Now in this topic, lenses are simply transparent materials. They're transparent materials, and a transparent material is a material that allows light to pass through it, and our eyes are also able to see through it. That's a transparent material. So lenses are transparent in nature, so they allow light to pass through them. We are also able to see through them. Now we are looking at this topic because lenses are very important. We use them in very many ways in different gadgets. For example, we use them first of all, our eyes. We see because we have lenses in our eyes. That's number one. The other one, we use them in cameras. We use them in microscopes. Okay, we use them in our glasses, lens glasses. So all those are applications of lenses. So it's very important to learn how these lenses operate. Now we also going to use the principle of refraction of light. Now, to understand refraction, let's go back and remind ourselves what is a refraction, because we'll be needing it here. So light moves in a straight line. We learned that in Form 1. The light travels on a straight line, the linear propagation of light. Now, if light moves and then it meets a boundary, a boundary simply means it is that interface between two transparent materials. For example, we could be talking about air, and then we have water. So the boundary between the two is the one that we are referring to. So we say the two have different optical densities. They do have what we call different optical densities. Now when you talk about optical density, this is not the same density that we have learned in other materials. Optical density simply is a measure of how fast is light able to go through a material medium. Okay, light is able to go to move in some material medias at very high velocity, and so we say those materials have low optical densities. It is able to, in some materials, it moves at a lower speed, and those materials are said to have a larger optical density. So it's a measure of how fast light is able to move through the material medium. So air and water are two transparent materials, and they have two different optical densities, with air being less optically denser than water. Okay. So at the boundary, we normally draw a normal. So what is a normal? A normal simply is a line that cuts another line at right angle. Okay, so this is a normal, and that is 90 degrees, 90 degrees, 90 degrees, 90 degrees. So a normal simply cuts the boundary at right angle, so we call it a normal at that point. So that is the normal at that point. And let's say we have a ray of light that is coming incident to the boundary. Now that is the incident ray, is a ray that is coming towards the boundary. Okay, then it hits the boundary at the normal. The angle there is, we call it angle of incidence. That's the angle of incidence. This is the incident ray. simply a ray that is coming towards the boundary is the incident ray. The angle between the normal and the incident ray is the angle of incidence. Then when that ray hits the boundary, now we know that light should travel on a straight line, but only when it is traveling through the same material medium of the same optical density. But when it is moving from a material of one medium to another medium, and the optical densities are changing at the boundary, then the speed of that ray of light will change. Okay? And because the speed of that ray changes, then the direction also changes. Okay? So this ray will not continue on a straight line. It might bend towards the normal or away from the normal, but that depends. So in our case here, the ray is going to bend towards the normal. Why? Because it is moving from a less optically denser medium and entering a more optically denser medium. I said optically denser simply means it is moving in a material where it can no longer move fast as it was moving before. So it has to slow down because the material is more optically denser. So in that case, the ray moves towards the normal. So this is the now refracted ray. And this is the angle of refraction. So we learned this in the topic of refraction. It's just a recap. So we have the angle of incidence and angle of refraction. We are talking about refraction now, not reflection. Remember, reflection has to do with light bouncing back from the source. Here, light is not bouncing back because the material is transparent, so it passes through. But it is bending at the boundary, and that bending at the boundary is what we call refraction. So with that, now we'll be able to understand our lenses better. So lenses are transparent, and there are two types of them. We have the one we call convex, and we have the one we call concave. So I can call this biconvex, and I can call this biconcave. Cave from that cave, inside that's a cave, so biconcave. And biconvex, that's a convex shape. Remember convex mirrors and concave mirrors. So this is bi simply means two. So there are two convex, since there are two sides, so biconvex and biconcave. Now, using the principle of refraction, this convex is a converging lens. So meaning, if a parallel ray comes towards it, like that, then these rays will be converged at a point. Okay? So is a converging lens. So a biconvex is a converging lens. Now what about the biconcave? It's the opposite. So if you have a parallel rays moving towards it, then those rays are made to move separate ways like that. So a biconcave lens is a diverging lens. So that is very important. Okay, that is very important. So we have two main types. Of course, we have others: planar concave, planar convex, where the one side is a plane surface, is flat. But the ones we are going to be using here is the biconvex and the biconcave. So we have said the biconvex one is a converging lens. So when rays are coming parallel to each other, then they are made to meet at a converge at a particular point. So that's why we are calling it converging lens. The other one is a diverging lens, biconvex, meaning when rays are parallel to each other and they meet the lens, then they are made to move their separate ways. So they diverge from each other. So it's a diverging lens. Now the other very important thing I want to discuss in this lesson is these lenses, we get them from spheres, okay? So like bias, remember we have two sides, so we are going to have two spheres. So if we have two spheres that are intersecting like that, and this is very important, then this is our lens. This piece here is our lens. Okay? So this, the first sphere, we call this sphere 1, and that sphere 2. Each sphere has a center. Each sphere has a center. And so the distance from any part of the sphere to the center, whether we are moving from this end to that end, remember this is part of our lens now, or from that point to that point, that's a radius. That's a radius. And we'll be calling that radius the radius of curvature. So we're going to look at some terms that we'll be using in our lenses. Now that is one. Then there's a distance from the center here of the second sphere to the other end. Remember now we are talking about this end here. That distance here is also a radius. So this center, we'll be calling it the center of curvature, which is the center of the sphere, from which our lens is part of that sphere. It is the center of the sphere of which our lens is part of that sphere, is the center of curvature. This is the center of a sphere. Remember, we're getting this, I want you to see these lenses as if they are coming from these spheres. Now the other thing we need to look at is now the distance from the center of a sphere to any part of that sphere. That's a radius. So be calling that distance from the center to that point, be calling it the radius of curvature. So we'll be talking about center of curvature, and we're talking about radius. So those are two terms that you need to remember as we go on with our topic. So the center of the sphere of curvature is simply a center. It's like the center of the sphere. The center of the sphere from where we got our lens. The radius of curvature, anytime we talk about from the center of a sphere to the any part of the sphere, the circumference, any part of the circumference of that sphere, then that is called a radius. So be calling it the radius of curvature. Now, and we have to note that this end, this side of our lens, its center is on the opposite side. And this side, the center is on the opposite side. So when you're talking about this end, the center is there. And this other part of this lens here, the center is on this side. So lastly, when you look at the biconcave, it's also coming from two spheres. So that's our lens. Okay, that's our lens. So there is a center of that sphere. There is a center of the sphere. Only that this time, the center from the center to the lens, to the part of the lens, and from the center to that part of the lens, that's the distance. Okay. So this is still the center of curvature. It is still the center of curvature. And that distance there is the radius. So it's the radius of curvature. So lastly, there is the center of the sphere, the center of the lens. That center is very important. I'll be calling it the optical center. We'll be calling it the optical center. It is the center of our lens. So it's very important to note it. It is called the optical center. So we have learned the center of curvature, which is the center of the sphere from which we got our lens. We have the radius of curvature, which is from the distance from the center of curvature to the optical center, something like that. Then we'll be looking at the optical center is the center of the sphere. So we'll be looking at why these three parts are very, very important. So that is the lenses. So we have said they are transparent materials. And being transparent means they allow light to pass through them. They do not reflect light. They allow light to pass through them. And because they allow light to pass through them, and this light is not coming from another, is coming from another transparent material like air, for example, or from water, and it is moving from one material, which is from one optically dense material to another optically dense material, but the two optical densities are different, then we are going to have refraction. That is bending of light at the boundary of two materials of different optical densities. And because of that refraction, then we have the situation whereby these lenses will either converge the rays of light or they are going to diverge the rays of light. The source of these lenses, we are seeing that we are getting them from spherical shapes. So these spheres have centers, so we are going to have centers of curvature, radiuses of curvature, and optical centers. So that's a good introduction for our topic of thin lenses. So I hope to see you in my next video. Don't forget to like and subscribe. So for now,